Okay, everybody, so this is yet another strategy for solving systems of equations, which is solving by graphing. And so what we're going to do is I'm going to demo this a few times, and we're going to look at a couple special cases. One where we would say that our equations within our set are inconsistent equations, and another where we would say they are dependent equations. So what we're going to do to start out, recommend graph paper if you got it. I will not be using graph paper. I'll just be kind of sketching my graphs onto this, this doc. And here we go. So we have a system solved by graphing. And I want to point out that just as with all of our other strategies for solving systems of equations, we can check this strategy using our other ones, substitution and elimination being the ones that we have so far. So keeping that in mind, what we're going to do is that we're going to graph these, each of them on the same axis, and in doing so, we are going to figure out where they intersect, and that intersection point is actually going to be the x and y pair that both of these have in common. So I sketch my little coordinate plane here. I put my little hash marks. Again, I think that ideally you'd have graph paper for this, but if you don't, you can just do what I'm doing. All right, and now I'm going to graph our first little equation here. I'll do it in blue, which is the y equals x plus 1. So 1 is our y-intercept, so I know there's going to be a point there. And then the slope is actually a 1, because remember there's an invisible 1 in front of that x, which would be our slope, which means we'd go up 1 over 1. 1 over 1. Connect these, and there's our line. I'm going to do it, the next one in green, so we have negative 2x plus 4. And so I'm going to recognize that 4 is the y-intercept for that equation. My slope is negative 2, which means down 2 over 1. So from here I'll go 1, 2 over 1, 1, 2 over 1, and that's enough for me to sketch in that next line. Now, we can see clearly that there's a point of intersection right here, and the coordinates of that point happen to be 1, 2, which means that the solution to this system is 1, 2. Now, of course, we know that we can plug this into both equations to double check to make sure that this actually is the pair that satisfy this system. I'm going to just do that out loud. For the first one, it would be 2 equals 1 plus 1, and that is true. And for the second one, it would be 2 equals negative 2 times 1 plus 4. Well, negative 2 times 1 is negative 2 plus 4 gets you positive 2, so we're all set. All right, let's take a look at this next example. I'm going to sketch my coordinate plane here. All right, and we talked about how to graph things like this, so hopefully you can put that to the test. Okay, put the first one in blue again. The y equals 2 line. Well, the y equals 2 line is actually a horizontal line that goes across the y-axis at 2. That should be a line straight across, parallel to the x-axis. And again, you can kind of check, this is all the points on this line are where y equals 2. And then you've got y equals x. So what I like to do with this one is recognize that, in fact, all of the coordinates are going to be the same. So 0, 0, 1, 1, 2, 2, 3, 3, etc. Sketch my line in. And recognize the point of intersection, which is right here. And it looks like that point is 2, 2. So there would be my solution. And again, you can plug them in. When y equals 2, 2 equals 2. And when y equals 2, this would be 2 equals, when x equals 2, that would be 2 as well. So we're all set. All right, let's do another one, solving by graphing. Sketch my line. It's nice when they're in slope-intercept form already. That's really helpful. Okay, and I'll make the first one green and the second one blue just to switch it up. All right, so first one is y equals x plus 2. All right, the y-intercept is at 2. Looks like the slope is going to be 1, so cross to the right 1, up 1, to the right 1, up 1, and there's our line. Okay, now we go to y equals x minus 1. All right, so I go to minus 1, which is where the y-intercept is. I got a slope of 1 again, so I go up 1 over 1, up 1 over 1, and I connect. Now, one of the things that you might notice is that it doesn't appear that these two are going to cross anywhere. So what we would say in this case is that these are a pair of inconsistent equations. And so they have no solution, which this little symbol here means no solution or empty set, right? And the way that you recognize that is that if you have two lines that are parallel to each other. And you might also notice that these have the same slope but different y-intercepts, which means that they're going up by the same amount. They're going to miss each other every time. So something to be aware of, inconsistent equations. There you have it. Is a set of dependent equations. So I'm going to go back and I'll write. Right. Let's look at the last example here. So we have another pair of equations here. You might notice that these are not in slope-intercept form. So what I'm going to do is I'm just going to quickly solve them for y and make sure that they are in slope-intercept form. So I'll start with the one at the top here. So the y minus x equals 2 can become y equals x plus 2. On the bottom, I'm going to maybe do a little bit more work here, but I'm going to add 2x to each side, so I end up with 2y equals 2x plus 4. Divide each side by 2, and then we end up with y equals x plus 2. All right. So if I went ahead and I threw this, here's my new set of equations, by the way, right here. If I went ahead and graphed these, which I will do, what is going to happen? Well, they're the same equation. They're actually equivalent equations to each other. And what this amounts to is that they are actually going to have the same solutions, right? Every single x and y pair that works in this first equation is also going to work in this second equation. So what we would call these for you, right? This is a set of dependent equations which means that they have the same solution set, or all real numbers is a way that you can write that. Now I'm just going to go ahead and graph this real quick so that you can see it, right? It would be at 2, and then you've got a slope of 1, so up 1, 1 like that. And so the line would look like this, but obviously if you graph the bottom one, it would be the line that's on top. So every single point on the first line is the same as the points on the second line. Give these a shot and see how you do.